Hey folks, when you sign into your company dashboard, your request hits the Laravel application. That's the entry point for all tenants. But behind the single app, a sophisticated multi-tenant architecture operates. It needs to identify which tenant you belong to, connect to the right database, process async tasks securely, cache data safely, and monitor everything. In this video, we'll peel back each layer to reveal the full picture. Let's dive in. The first layer is the tenant resolver middleware. This component intercepts every request and inspects the domain or subdomain to determine the tenant ID. It then sets the tenant context on the request, which all downstream components rely on. Without this middleware, the app wouldn't know which database, cache, or queue to use. Think of it as a smart switchboard that routes each tenant's traffic correctly. The resolver also loads tenant specific configuration like branding, permissions, and feature flags. This is the foundation of multi tenancy in Laravel. It's lightweight but critical. Once the tenant is identified, the resolver dynamically selects the tenant's database. Laravel's multi database connection feature allows switching the connection based on the tenant. Each tenant gets their own database or schema, ensuring complete data isolation. The connection is configured on the fly using Laravel's database configuration repository. This means your models automatically query the correct database without any manual work. The same pattern applies to scoped models, where all queries include a tenant scope. This ensures security and compliance. Database isolation is a key decision in multi tenant architecture. For tasks that don't need immediate responses, like sending emails or generating reports, the app pushes jobs to a queue. Each job carries the tenant context as metadata, so the worker knows which database and settings to use. Laravel's queue system supports multiple drivers like Redis or SQS. With the tenant context, you can even route jobs to tenant specific queues for better isolation. The queue worker then processes the job, restoring the tenant context just like the original request. This enables async processing at scale while maintaining tenant separation. It's a powerful pattern for performance. To handle high traffic and potential failures, we introduce caching. Cache keys are prefixed with the tenant ID, so each tenant's cache is separate. This reduces database load and speeds up responses. If the database becomes slow or goes down, the cache can serve stale data, improving resilience. For writes, cache invalidation is scoped to the tenant, preventing cross tenant leaks. This caching layer is critical for scalability in multi tenant systems. It's typically backed by Redis or Memcached. With the tenant scoped cache, you get both performance and isolation. This is a simple but powerful resilience pattern. Observability is essential for managing multi tenant systems. We collect logs, metrics, and traces from every component, each tagged with the tenant ID. This allows us to monitor per tenant performance, detect anomalies, and debug issues quickly. Tools like Laravel Telescope or external APMs provide visibility. Without observability, you would be blind to which tenant is experiencing issues. It also helps in capacity planning and cost allocation. By centralizing logs and metrics, you can correlate failures across components. Observability turns a black box into a transparent system. It's a must have for production. Security is the final piece. Authentication middleware validates the user's identity and checks their tenant membership. Authorization policies then restrict access to tenant scoped resources using Laravel's gates and policies. This defense in depth approach ensures that users can only see data within their own tenant. Combined with the tenant resolver, it creates a secure boundary. The auth system also handles session management, password resets, and two factor authentication per tenant. This layer is critical for compliance with data protection regulations. Without it, multi tenancy would be insecure. Now you have the complete picture. When you sign in, your request flows through the tenant resolver, selects the right database, processes async jobs with tenant context, caches data safely, is monitored and secured. Laravel multi-tenancy works only when tenant context flows through every layer: middleware, database, cache, and queues. Each component is designed to carry that context, ensuring isolation and performance at scale. This architecture enables you to serve hundreds of tenants from a single code base while maintaining security. Thanks for watching this deep